In previous video, I shared the hardware of the home solar battery V2. In this video, I'm going to share the control logic which is done in Home Assistant. This Home Battery 1, this is the mainly control logic. So first, let's have a look over the battery voltage. The battery voltage is measured by the microinverter. In previous video, I mentioned the Hoyle-Myers inverter can measure the DC input. As the DC input is direct connect to the battery, so it actually measures the voltage of the battery. This is very useful for control. So you can see the battery voltage like here is 25.1 volt and the top is 25.5. So this is likely the lowest is likely stop discharging, and the highest is likely the voltage stop charging. I will go into more details later. There is one thing is the voltage from the microinverter actually have glitch, so I have to filter out. So if you look into here, so this is a low voltage from the microinverter. You can see sometimes jump to 0 volt. So what I did is I filter it out. So if you're looking for the battery 1 voltage, all this glitch is gone. So how I do that? Let me show you. So this one, I think it's the battery 1 voltage. It's a sensor template, and in here in the template, if I get voltage of the microinverter on port 1 DC voltage first, if the voltage is greater than 0, then get the voltage, otherwise it won't update it. So this is how I filter out the glitch. And as long as we know the voltage now, the next step is we control two signals, which one is the empty signal. This is when the voltage is very low. We can go to this update full empty. This is the logic controls updates the full empty. So when the battery 1 voltage changes state or every minute, so if the voltage is about 27.5 volt, then turn on full. So I'm using 27.5 because the two battery I'm using are different size. One is 75 amp hour, another is 100 amp hour. So usually only one battery will get full and another battery is not full. This is kind of situation when the two battery is out of balance. So I choose the voltage 27.5. As long as one battery is full, the power to the charger will be cut off. It will raise the full flag, and then it will stop charging. And if the battery voltage is below 26.6 and above 10, then turn off full. So this is where the battery 1 full turn off, So turn on is above 27.5 volt, turn off is below 26.6. So there is a gap of 0.9 volt, and this is avoid the battery one full status to be toggled too frequently. And the next is how we update empty. If the battery voltage is below 24.7 and above 2, this is to avoid the glitch. As I mentioned, there is a glitch of this voltage, and the input it will turn on battery 1 empty. So as long as the voltage is below 24.7, it will turn on. So this is when one battery is empty, then it will trigger the BMS will shut down this battery. It's empty, and then it protects the cells inside. It will shut down the battery. Then the whole voltage will drop. So as long as here I'm using 24.7, and then when the battery is come back to above 25.3 volt, so it will turn off the empty. So again, there is about 0.5 volt gap here to avoid the battery 1 empty to be turned off too often. So this is the battery full and empty. And empty, we can see in the past, for example, in the past week, it's almost no triggered. And let's say full. Full should be triggered every day, I think. So you can see about here, it's full. It's full. This is at 3 o'clock, 3:40 afternoon, and it's full. Then at 5:21, it's 5:21. It's go off. So yeah, when it's discharged, it go off. So now, then there is a two interesting power is battery. This is the inverter power. The inverter output I limit to 400 watt. The reason for that is the cable I'm using is 2.5 millimeter square, and it's getting warm if I don't limit it. I think it should be still safe. I think the maximum, if I don't limit it, is maximum is 600 watt for both DC input port connect to the battery, and just for actual safer, I limited the output to 400 watt. And there is a charger power. Let me see. So the charger power, as I mentioned, it's a Victron charger, and this is turned on off by a smart plug. And when it's turned on, it's charges the battery at about 350 watt. So this is I believe I set the charging current to 12 amp. This charger can go up to 16 amp. I limit the current again, just I feel the cable is a bit warm. So I think in the future, I plan to replace the cable with a thick one, 4 millimeter square. Then I can use the full current to charge it. And with this power, we have calculated a power called battery net power. So this is the power combined with the charging power, discharging power, and the self-consumption. We can go have a look how it's calculated. Again, it's a temperature sensor. So this is how it calculates. So it's the input charger current, charging power, and I put a efficiency of 95%. This is taken from the Victron charger datasheet, and then this is an inverter. Inverter again, I applied about 5%. Again, about 95% efficiency. So, and then I take of 10 watt, which roughly is the self-consumption of the circuit, even is not charging, is not discharging, and the battery, the BMS, is consume power, and the an inverter also consumes some power. So here I put 10 watt to compensate the idle power. And the net power, when we integrate it, then we get energy. So it's called battery 1 energy law. So this is basically the integration of the net power. You can say the power, this is charging, and then sometimes discharge and charge again and discharging, and this is battery nearly empty, and then it's um, um, discharge at 10 watt. It's the idle power I factor in, and then it slowly go down. So this is a low energy, and then there is a offset. So to calculate the real energy, we add the offset. Then between the offset, combine the offset and low energy, we got the true battery energy. At the moment, it's um, just about 1000 watt hour. So let's see how this is calculated. So again, let's see. So this is a template. So it's energy low plus offset, and the offset is automatic updated when when the battery is full, so it's set to the maximum the energy, and then when the battery is empty, it's set to 0. I show you the logic now. Let me show you the logic. So the offset is automatic update. Let's say it's late. There is an automation script which update energy offset when energy below 0. Let me say what's this one. So this one is when battery energy is below 0. Clearly we don't want to go to negative, so it will automatically update the offset to make the energy 0. When the battery energy is above capacity, so there's the input say what's the battery capacity, and if it's above capacity, then we also update the battery energy offset. So this is say what? So it takes the value of input battery capacity minus battery energy low. So basically you will get when it's above capacity, it will be limit to the capacity. So this is how the offset is automatically adjusted. So let's see if we can see some how this is adjusted. Let me show more. And the full week. Didn't say something here. Anyway, let's carry on. And then the charger, let's looking for the charger. Charger is controlled by a smart plug. So this is the charger power, current, and the voltage. Of course, it's off at the moment. The charger, how we turn on the charger? Let me have a look. So turn on off charger on solar power. So this is how the control works. If the charger is off and the battery target power is below -500 and the battery is not full and the battery charge enable is on, then turn on charger. So and delay 5 minutes. So what happened here is we want a target power. So if it's a -500, which means we have 500 actual power from the solar, then we turn on charger. And this is how we turn off the charger. So if the charger is on and if the grid power is above 100, the grid power, if it's positive, which means the house is taking power from grid. If it's a negative, which means the house is exporting power to the grid. So below 100, so which means the house is consume 100 watt from grid. And if battery full is on, so or any of these two conditions match. If battery is full or the grid will consume 100 watt from the grid, then turn off the charger. So this is how we turn on off the charger. One of these we just mentioned is the target power. So this is the target we want the battery to charge or output. If this is a minus, then we want the battery to charge. If it's a positive, we want the battery to output. So let's see how the logic is done here. So it's a temperature sensor. So it equals grid power home. So it's grid power plus battery wants AC power. So battery AC power, this is the inverter output minus the this is charger input. The plug was using for my Anker C1000, so the name is not changed. So this is how it's work out for the target power, and this target power used to control the charger as well as the inverter. Let's just have a look at how inverter is controlled. First, inverter is on-off switch. The inverter is integrated to the home system. Then there is on-off switch, and let's say go to the related. Turn off AC output by battery charge. Turn off inverter AC switch. So this one. So trigger every 35 seconds when when battery 1 empty change or battery discharge enable change. So if 7 condition match, if the AC switch is off or battery AC power is below 2, if the empty is off, to turn on the inverter, the battery must not empty. Battery discharge enable must be on, and the target power should be above 50 before we turn on the inverter. And the battery 1 energy is above 10. So if the battery energy is below 10, it won't turn on the inverter. If the charger is off, when the charger is on, we don't want to turn on the inverter. If the battery 1 SOC is above 5, so battery 1 SOC is state of charge. It's from 0 to 100%. So it's needed to be above 5% minimum to turn on the inverter. And then is how to turn this off. So when the inverter is on, when the AC power is above 2, then if any of 6 condition match, empty is on or empty is off, but the battery target power is below 0. If battery energy is below 100 watt hour, if the charger is on, if the discharger enable is off, if it's not enabled, if the SOC is below 5, then we turn off the inverter and also set the inverter power limit. Inverter power limit here is the minimum is 2%. You can set it from 2% to 100%. In 100% equivalent to 600 watt here. In my script control, I limit to 50, which is about 400 watt. And then press button turn off. So this is a turn off the inverter. This is the battery 1 AC switch. This is a sensor. This is a helper and Boolean input. So I just use this to indicate. So in case if I need to control 2 inverters, then this will be the master switch. Okay, I forgot to mention battery SOC. Battery SOC is state of charge. It's basically the current battery energy divided by the battery capacity. Let me look into the template. So this is the battery energy times 100 divided by battery 1 capacity. And the default value is it's hard-coded 1800. The battery capacity, by the way, you can adjust here. So at the moment I'm setting to 1700. In serial, my one battery should be 1900, something like this, because I have 2 different size battery combined. And I found a set to 1700 to avoid triggers empty. So basically, before the battery is empty, it will shut off the inverter. So currently you can see the target power is 394, but the in AC power is 363. So this is the battery output 363. So although its target is this one, but we haven't reached it yet. So I tell you what's the reason for that. So one of the things is this is battery 1 DUT power limit. So this is adjust the power of the inverter, but there's a limitation. You can't update this too often because this parameter is saved in the EEPROM of the inverter. If you update this too often, you will wear out of the EEPROM. Basically, the EEPROM have a limit right um, cycles. For example, it's 10,000 or maybe 100,000. I didn't check the data sheet. They didn't disclose it, but I know it's saved in EEPROM, so we want to limit the time frequency we update this one. So what I implement is, so this is the power limit currently 54, and then the target limit is 50, and the delta between these two is 6. So as long as the delta is getting bigger and the limit haven't been changed for a long time, so I call it the limit steady. So what it means is maybe it's here limit steady. So when the limit change is it's reset to 0, and then it just start increase, and when we know the last change, how many time elapsed from the last change, then the automation script can update the power limit from the target limit. Let me show you how it is done. So this is, let's say, related. Update inverter output limit. So here, trigger every 2 minutes. So if AC switch is on, limit steady is above 15, and the delta limit is above 5. So basically, if the gap is 5, the target limit and the current limit, which is the delta, the difference of the target limit and the current limit, which is the delta limit. If the gap is 5, and then the limit haven't been changed for 15 minutes, then we update the power limit with the target limit. Or if the AC switch on and the delta is above 25, so each 1%, each number is about 8 watt. 25, which is about 200 watt. 200 watt. Then if the steady is above 10, we update it. So here is above 5, which is 40 watt. And then there is another is if the delta is about 40, which is 320 watt, and then its limit steady is above 5. Again, this switch need to be on, AC switch. Then we update the power limit. Okay, let's say the limit steady, how this is done. So limit steady is in reset limit count or limit adjust. So it's reset when the limit is adjusted, and then it's increased every minute. So it's simple like this. So increase every minute it's increased by 1. So this is how I avoid to update the power limit too frequent, too often. And now Again, these similar things apply to the charging. We don't want to turn on off the charging too often because this first is unnecessary, and the more I'm worried about is every time you turn on the charger you introduce inrush current, and there's more chance that you will um, damage the charger. So again, in the charger I also implement called charger change steady or something. Let me have a look. Limit steady, charger steady. Every time the charger changes status, then this charger steady will be reset, and then um, when it's time we update the charger, I think let's say related turn on off inverter, turn on off charger. So turn on off charger, so when it's off, power is below, enable or turn, this is turn on, this is turn off. I think the charger steady is not used here. I might have forgot to implement it. Anyway, so the intention is for this is to avoid change too often, but I have had a hard delay. I show you. I forgot to show you. Let me show you again. Related. So every time after I change the state, I have a force delay for 5 minutes. Basically, the charger change will at least 5 minutes. The reason for that is the mode of this automation is single. So while it's on the delay waiting for 5 minutes, it won't be triggered again. So basically this force you turn on the charger at least 5 minutes. Okay, let's see some interesting chart. So this one basically shows the voltage, battery voltage, and the DC voltage of the inverter. This one shows so this blue one is charging power. So when the charger is on, and this is the net power of the battery. So either charging or discharging. So this is discharging, this is charging. And the battery AC power. So this is inverter output power. Sometimes, most of the time, it's 400 watt. Sometimes it's small, and this, for example, it's 300 watt, 400 watt. This is 300 watt, and here is 50 watt. And this is energy, and you can see the low energy currently is discharging is go down, and this is battery energy, so it's peak at about 1700, and then now it's discharging. It's now only have 900 watt hour left. Battery capacity, this is set to 1700. The next chart is battery step is not used. Target limit. This is target, the target, and then there is a delta. So what's the difference between the target and the current limit? So this is delta, and so this is a true power limit number. So basically, I'm using the power limit feature of the microinverter to limit the output. to match the power consumption of the house. So next, this is SOC, state of charge, and this is some of the control or sensor from the inverter, the voltage, temperature, turn off, turn on, and this is daily energy. This I don't know what this is for. It's basically something information provided from the microinverter. And this one, oh, this limit. So we have been go through this one. This image energy discharging. This is grid power. It's go to negative. And sometimes positive, negative. Yeah. So this is the power, and this is the battery voltage. 25, 26, and 25. And this is a limit steady signal. Well, we have talked about this. Battery SOC is 50% at the moment. Battery voltage again, and charger voltage, charger current. Grid power, battery AC power. So this is output power: 300 watt, 0 watt, 300, 360, 400. This sum of the grid power. Yeah, you can see the grid power is actually can go up to 2000 watt, even more. But in my inverter output is currently limited to 400 watt. Maybe increase this in the future, but that's even the 400 watt. It will cover most of the base consumption of the house, and that's the most of energy went. So this is the SOC in the past 7 days. You can see it's go to 0 and charging, discharging, and then go to 0, charging, discharging. So it's every day. It's I'm quite happy to looking into this chart. It looks behavior very well. And this is battery voltage. You can see 25 volt and go above 27.5, and then go down to 25, sometimes 24.5. This likely will trigger empty signal, and then above 25, 27.5, it will trigger the battery full signal. And this is the battery energy. This is very similar to the SOC, and this is the battery net power of the in the past 7 days. Yeah, that's all. That's the major control logic of the home solar battery. And hope you find it useful. If you have any questions or suggestions, please leave the comments below. So this is as I mentioned, this is my second implementation. I'm looking forward to improve it. So I'm planning to add more battery, maybe increase capacity to about 7 kilowatt hour, and we'll add a charger to increase the charging power as well. And some of the wire is too thin. I need to change it to bigger to allow to me charge it faster. And anything else? I think I might looking for add a different kinds of inverter as well. So yeah, that's the battery. So hope you find it useful. Thank you for watching. Bye for now.